Hi, I'm Andrew, and using the Think Square, I'm going to show you that you already know all of these addition facts. To do this, you'll need to know just 4 things. 1. How to double numbers. 2. The commutative law. 3. How to add or subtract 1 or 10 from any number. And 4. All the combinations of numbers that add to 10. Alright, let's get started. The first thing is knowing how to double numbers. So, that means 1 plus 1, that's 2. 2 plus 2 is 4, 3 plus 3 is 6, and so on. So that's one fact that you need to know. What this does is splits the board into 2 triangles. And these triangles are actually reflections of one another. If you look at any 2 numbers, its partner will be over the other side somewhere. And this is the commutative law. Don't let the big words scare you. Commutative just means that 1 plus 8, if I flip it over or commute the numbers so they travel somewhere else, 8 plus 1 is the same as 1 plus 8. They both equal 9, and that doesn't change regardless of where they're put in this equation. So that's what commutativity means. And what it means practically for this is that 10 here, which is 7 plus 3, also is reflected over here. So if we know one of these triangles, the other one we know by default, because 3 plus 7 is the same as 7 plus 3. Just like 4 plus 2 is the same as 2 plus 4. And so we can wipe out one of these entire triangles because we know that law. Let me just do that really quickly. Alright, so already we've under-halved the number of equations we need to know now. The next thing we need to know is how to add or subtract 10 or 1 to any number. If we know that, we know all of these sums here. 10 plus 1 is 11, 10 plus 2 is 12, 10 plus 3 is 13, and so on. So I'll put a tile over all of them to show that. And we need to know how to add 1 to anything, which I assume we all do. So 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, etc. So we can put tiles over all of these facts as well. The last fact we need to know is the combinations of numbers that add to 10. So they're all here. 4 plus what? 6 equals 10. 3 plus 7 is 10. And 2 plus 8 is 10, and we've already covered the 1 plus 9 in our last fact. So these are the things, these are the 4 facts we know. And using a bit of logic, fact number 3 was how to add or subtract 1 or 10 to numbers. If we know these off by heart, 10 plus something, so 10 plus 5 is 15, 9 plus 5, which is 1 less than that, will be 14. And that's pretty easy to see. It's kind of like if you get lost somewhere, you find a street that you know where it goes to, and once you get onto that street, you'll know how to find your way back home. Same's true with maths. Sometimes you don't know how to do things directly, but you know something relatively close to that will help you find your way. So here, all these facts when we're doing 9 plus something is just 10 plus something, subtract 1. So 10 plus 2, well, let's do 9 plus 2, and it's going to be 1 less than 10 plus 2. So these are, I'm putting blue on them because these are secondary facts. We first need to know 10 plus something to know what 9 plus something is. So we know those, and we also know if we know all the 1 plus something, then 2 plus something is just 1 more than that. So we'll go through the 1 plus 3 is 4, so 2 plus 3 is 5. So this time it's adding 1 to each of our answers that we already knew. So this is a secondary fact as well. And when we look at all the double numbers here, we can go 1 less than them as well. So for example, we don't know this one at the moment, 4 plus 3. We do know 4 plus 4 is 8. And so 4 plus 3 is 1 less than that. And so we can use our knowledge of doubles, and this is close to a double, people call it near doubles, to figure out that 4 plus 3 is 7. 5 plus 5 is 10, but we don't know 5 plus 4, but we do know that that's 1 less than 5 plus 5, so we can put tiles over all of these ones, because these ones here on the inside of the triangle are called near doubles. They're almost doubles, but they're not quite. They're one off it. And so we can subtract 1 from there. Then we can use the facts with the tens and the things that are close to that. So we know that 6 plus 4 is 10. So 7 plus 4 would be 1 more than that. We know that 7 plus 3 is 10. So we know 8 plus 3 must be 11. And then going the other way, if 7 plus 3 is 10, so here, then we should know that 6 plus 3 is 1 less than that. So that's equal to 9. Now these are the only things we can't know within 2 steps of those 4 things I said at the start. However, if we remember just these 2 numbers here, that one and this one here, we'll know every number fact from 1 to 10 when you're adding single digit numbers up to 10. So if we get 8 plus 5, we know that's 13 now. We've done it in our head a number of times because we know this is the key one we need to remember. 8 plus 5 is 13. 5 plus 8, 13. So we know that. If we know 8 plus 5 is 13, then our secondary knowledge becomes 8 plus 6 is 14. Because we know this one, remember, we'll know the one above it. We'll also know the one below it. If 8 plus 5 is 13, then 8 plus 4 is 12. And we'll also know if 8 plus 5 is 13, then 7 plus 5 is 12. So we'll know all those ones around it because we use this one to get to them. And this one's just pretty simple. We just need to know that 5 plus 3 is 8. And so if we know those 2 and those 4 facts, which are doubling numbers, the commutative law, how to add or subtract 1 or 10 to any number, and all the combinations of numbers that add to 10, if we know just those 4 things, we know how to add everything here, all 100 facts.